Hello guys, I hope that you are doing well. So in this lecture we will cover the basics of junit and testing in Java. So I will cover things in theory and my colleague will explain how this is actually working. So he will explain things in actions, okay? So let's get started. So let's take a look of the history of JUnit. So Kent Beck developed the first X-Unit automated test tool for Smalltalk in middle of 19th. Beck and Gamma of design patterns Gango 4. So this book Gango 4 is really famous. I recommend that you take a look of this book. So Beck and Gamma developed GUnit on a flight from Zurich to Washington DC. GUnit has become the standard tool for test-driven development in Java. GUnit test generators now part of many Java IDEs, Eclipse, IntelliJ, Visual Code, and you can use any IDE you want, but in this lecture we will be using IntelliJ IDE. And for more details, you can check the official website gunit.org. So basically, what is GUnit? What is testing in software engineering? So testing is that we test is our software behave as expected. For example, how can you be sure if your application that doesn't have a problem or you didn't make a mistake while you were programming it? So you can't be sure, okay? So we have to test all our cases, or we have to test if our application doesn't have any problems, okay? So that this is why we use testing in software engineering. So as you see here is the types of automated test. So we have three common types of automated tests are unit. We have unit here, and we have the integration tests, and we have the end-to-end. As you see here, we have unit tests in the bottom. So as long as we go to the top of this pyramid, our application is getting slower and slower. And as you can see, there is a higher volume of tests at the bottom of the pyramid, followed by progressively fewer as you climb to the top. So the tests take longer to run as you go up the pyramid, but provide more comprehensive, realistic coverage. So let's check out the value of each one. So unit tests, we will take a look of unit tests. So what is unit tests? So basically, it's the biggest section at the base of the pyramid. So is unit tests that tests small units of code. So more specifically, they check that each individual class keeps its promises. So in unit tests, we test if classes if the methods in a class behaves as expected. So these are extremely quick, which means you can run a lot of them without having to sit around and wait for results. So if you have broken something, you know about it fast and early. So since they only test individual units of code, they can't tell you if everything in your application is working together correctly. And that's where some of these other tests come in. So integration tests. So what is integration tests? So integration tests are slightly slower than unit tests, so you don't write quite as many of them. So integration tests check if your units check if your classes are working together as expected, assuming your unit tests are correct. Of course, since integration tests check interaction between classes, you make fewer guesses about how well the final application will work. You sacrifice a little bit speed for realism. So integration tests, as I said before, integration test is that we test classes if is that we test if classes interact with each other correctly. So we have the last one, end to end. So what is end to end test? So they are the slowest. This this is the slowest test, but simulate reality more accurately. So they eliminate any remaining risk by proving your application works with users in the real world, assuming your classes and their integrations are correct. So, for example, this test could check whether users can switch your application on or achieve a goal. So, as I said, you only want a few of these tests here because as the higher up you go, the slower your tests. So, test to make maintenance easier. So, even if you miss some important test cases, having a good amount already in place can make fixing and maintaining code a lot easier. So here is an example of a team leader who tell us the importance of using testing, and that's make maintenance easier. So you can take a look of this example. So the test to communicate. So test lets the developers communicate with each other. Well, your test cases will describe how people expect the software to behave. So reading your test not only captures what your code is supposed to do, but also how it works and how much of it works. So if you write tests, another developer or even you in future, if you pick up the projects back a month later, will be able to understand what you were trying to do and be confident about making changes in the and be confident about making change to the code you were writing. So in other words, in a professional environment, testing is more than just a way to fix code. So it's a whole mindset. So set up your build tools and frameworks. So to create a unit test with junit for a class, you will start by creating another class. So this new one will hold all of the tests you will use to check your original. So this is usually created another under the src test java folder of your project. So and the test class is named after the one being tested. So structuring your first unit test. So now that everything is set up to test, how do you actually do it? Well, you have to set up a test within the unit framework. So we will be using here the Maven build tools. You can use Maven or Gradle, or even you can choose between them. So first thing you have to import or you have to include the GUnit dependency in the pom.xml, or if you are not working with the Maven, you have to add the jar of GUnit. So here we will be using Maven, and we added the dependency in the pom.xml. As you see here, the first thing we need to use GUnit. We have to import GUnit, and the second thing we have to add this add test annotation, and the the third step, the name of the test should describe what is tested, and we will cover this later in this video. So let's walk through each one of the steps one by one. So step one, so to turn calculator test this class. So to turn calculator test into a new GUnit test, we should start by importing GUnit's add test annotation with the following code: import org.gunit dot wildcard. So first, as I said, we should add the dependency of GUnit, and then we should import this GUnit. So what is annotation? Annotation tells GUnit what to do with the method after the annotation. So in this case, add test tells GUnit what we have a test which needs to be run. That's easy. So step 2, we have to place add test in front of a method. So to create a test with GUnit, we have to create a new class and add the add test annotation above each method which performs your test. So in the step 3, we write a descriptive name because of course to make other developers understand what your method is supposed to do. So as I said, the method name should clearly describe what is being tested. So it's important to give your tests a name which describes what the test is checking for. So how do you actually structure the content of your test? So to write a reliable test, it makes sense to follow the popular acronym AAA. So it stands for arrange, act, and assert. So the goal of this structure is to keep tests independent and avoid interfering with one with another. So we are going to act, arrange, and assert as our next step. And as you hear in this image below, in the step 4, we arrange. So in our arrange section, we just make a few of instantiations, and we arrange our variables that we will be using when we are asserting. In act, we just call our method that we will be testing, and assert, we assert if this method is equals to the result we were expecting. So as I said, in step 4 arrange, we set up the class under test. So arrange is another way of saying setup. So when you write a unit test for a class, you start by setting up an instance of that class you are going to test. Do this by calling new unit. So this is called your class under test, or in other words, the thing you are testing. And in step 5, act, we call the method you are testing, as I said before. Now that you have got your tests arranged, you will act on this. Basically, you product it with your testing one by calling its methods. So the methods should do something which you can check for or return a result. And in step 6, assert is that we check the results with an assertion. Now that you know what you are checking, you assert your expectations. So you want to compare an expected value with the actual value returned by the method you are testing. So if they match, your test pass. If they don't, you fix it so they pass. So you do this by adding an assertion. Now that you know what the steps are, let's take a closer look at the image again. So in the image above, the results of calculator under test dot add one is compared with the number 2. So using assert equals here, you are testing the assertion that two values are equal. So this is just one of the assertions GUnit makes available when you import org.gunit, like in step 1. So assert equals simply test that the returned value from calculator under test.add is the same as the value you expected to get back. So as you see here in this image, whether you're using IntelliJ or Eclipse, you can now right click on the test name and select run. So the above example was run using IntelliJ as this image. So have a look at the green tick. Can you tell what is testing? So we are testing, it should add two positive numbers. So adding two positive numbers correctly, because we have the green mark here. And it looks like in the test has passed. So this is as I said before. So had the assertion failed because the add method was buggy, you would have seen something like this. You have seen something expected, for example, 2, but the actual value is 0. So you can see that the test failed, it has a round cross beside it, so as the actual 0 in this case didn't match the expected value. So now we will talk about an important principle of TDD, test the test driven development. So the read, or we call it the read green refactor. So you might have noticed that we started writing tests before anything else in the code. So this follows this technique called test-driven development, or TDD. So using this technique means the code you build remains focused on passing those tests. So you know already what you want to do. So did you notice how writing the test before the code allowed us to describe what the add method would look like? So from there we just had to allow our IDE to create it for us, to create our methods or our classes for us. So here is the diagram of TDD. Kent Beck, the creator of TDD, introduces many developers to the following pattern. So we write a failing unit test, then we write the code to make the test pass. So we clean up code without failing the test, and we write the next test and repeat. So we start by writing a failing unit test, then we write the code to make that test pass, and we clean up the code without failing the tests, then we write the test again and again. And here is, as I said before, we write a failing unit test, and we write the code to make that test pass, and we clean up the code without failing the test, then we write the next test, and we repeat the same step again and again. So writing test is easy to read test with Hamcrest. So when we will introduce a new library, Hamcrest, that allow us create assertions methods with an easy method, with easy way. So did you notice how the test in the previous chapter used junits assert equals? So we can't in our lives we can't say assert equals in our lives. So would you ever see assert equals in everyday life? Of course not. So you want the test to express what your software should be doing. So tests are tools for communicating with yourself in the future, or communicating with other developers. So as well as the others. So if you understand now it should behave, then you know if it works. So there is a popular library called Hamcrest, which many Java projects use to make their test assertions a little more natural to read than junit's assertion. And it uses language that we are using in our lives, and we will see that later in this video. So it is designed so that your code follows naturally and more closely, and more closely resembles spoken language. And this is what I said before. So writing easy to read test with Hamcrest. So you can see the difference between Hamcrest and GUnits. So assert true in this example, assert true will only pass if the value you pass it is true. So let's compare it with Hamcrest's more expressive language. So this is how we do the assertion in GUnits, and this is how we do it in with Hamcrest. So and as you see here, using Hamcrest make assertions easy because we are using our language, English. We are using the language that we are using in everyday life. Uh, as you see here, we make assert true name dot length, and we make this condition. And in this using Hamcrest, we use this assertion method, assert that. So this is more comprehensive, aren't it? Isn't it? So we use the name dot length, and this is the condition. So let's so let's use Hamcrest to do some TDD. So you will get Hamcrest most important matchers for free, as they are included with GUnit 4. So they just come together, and if you use GUnit 5 you will have to add a dependency for it, as it's no longer built into GUnit. So if you are using a GUnit 4 Hamcrest, it's already included to it. But if you using GUnit 5, you have to add a dependency for Hamcrest. So let me give you some other examples. Imagine I had a set of animals and I want to test that it contained cats and dogs. So I write like this: assert that animal set has items cat and dog, or assert that animal set contains cat and dog. So as you see here, using Hamcrest, using assertions with Hamcrest is really easy. So how natural it sounds is down to the matchers you use. So these are just two of the mini matchers provided by Hamcrest. They come in all shapes and sizes with lots of different vocabulary. Some of the more useful ones are, look at these matchers. So is, we use that matcher to compare two values. And here is the example: assert that a kitten is a kitten, or assert that a kitten is equal to a kitten. And this is what happens when the test fails. So we have the other matcher here, we have equal to, and this is and this is how we use it. So assert that a kitten equal to a kitten. So we assert that this string is equal to this string. So this is what happens if the test fails. Not, we have the not matcher. So it asserts that this string is different to this string. So this string is not this string. So expected is not a kitten but was a kitten. This is what happens if the test fails. And we have these matchers, and we have so on and so on, so more. And if you want to say, if you have to see a lot of these matchers, you can visit the official websites, junit.org. So create more powerful tests using GUnit annotation. So there are many useful annotations which come with GUnit, and I will introduce some of these to you. They can help make your tests super powerful and save your lines of code. So to use this annotation, drop them into your test classes. So we are going to add a few annotations to our calculator test. The test class should be named after the class under test. Since we are testing a calculator, let's walk through a calculator test which uses basic annotation of before class, at after class, at before, at after, and some special spins of the at test annotation. So let's dive in. So as you see here, we have added a stat. We so this is the class we are testing. So we have added a static variable here and the class field to use an example above. Now let's check out the at before class. So what's actually the do this annotation? So this annotation uh, and the at before class will cause a method to run once before our first test. In this example, we store the time when the tests were loaded. Next is at after class. So the at before class is simple do. What is simple do is just it run once before all the tests. So what we need it when we want, for example, the instantiation or arrangement. So so here is the way we are using it. So let's take a look at the at of this annotation at after class. So at after class marks a method to be run once after our last test has completed. So this will run even if the test failed. Here we measure how long it took to run the test. So this is a we use this annotation if you want to, for example, to clean our code, and it runs once after all the tests. So what is the as before annotation? We have as we have seen here, the as before class runs the as before class annotation runs once before all the tests, but this annotation runs each time before each test. Okay, the at before marks a method so it can be run before each at test. Here we make sure that we have created a new instance of calculator. So the most of we when we are using this annotation, we all we are we use this annotation if you want to do some arrangements and instantiation. As you see here, we use this method to do instantiation and arrangements. So now we have got the at after method. So at after method is an annotation that it runs each time after each test. So after marks a method to be run as soon as junit has finished running at test. So this is often used to clean up things done in at before. So you have already seen the at test annotation. So junit's annotation helps you write a clearer test without unnecessary repetition. So some common annotations here, and as I said, we have at tests to if testing method which should not be too slow, you can force it to fail the test. We can use the timeout milliseconds. For example, if you want to determine a specific time, and if the test is uh, is taken longer that time, the test will fail. And we have here the expect exception. So we use this annotation to test if your class throws an exception. And we have here as before annotation. So as I said before, this annotation run a method prior to each test. So this is a great place to set up our or to arrange a precondition for your test. So as I said before, here we use here we in this annotation we do arrangements and we do instantiations, and we have the at after annotation. We run a method after each test. So this is a great place a place to clean up our or satisfy some post condition. We have here the as before class. So we mark a static method so it runs before all your tests. So you can use this to set up other static variables for your test. And we have the add after class, and here we mark a static method as being run after all your tests. So you can use this to clean up static dependencies. And if you want to see more of these annotations, you can check the official website junit.org. So label your test with advanced unit annotation. So we use add category to label similar tests. So we use that add category to group tests together. So for example, so GUnit 4 comes with some useful annotation which let you label your tests, a little like making which chapter or topic they fall under. So if someone asked about where to find your tests on, say, temperature conversion, you could find all of them quickly by labeling them with same category name. So GUnit 4 provides add category for this very purpose. So every class or method you want to label gets annotated with add category. So let's check out this conversation calculator with the line numbers on the left. So have a look at line 1. All the tests in the conversation calculator test class have been marked as conversion tests. So line 7 additionally marks one test as Fahrenheit test. Line 7 and 14 mark two tests. Here is the image. So the line 7 and 14 marks as categories dot temperature test 7 temperature test. So take a look of this image. So add category has one slightly annoying restriction that the labels you use here should be classes or interfaces. So to label tests are as Fahrenheit, we should create an interface which contains all your labels, like below. So then we mark your class or test with categories Fahrenheit test. So we use the add tag to categorize tests more easily. So far we are focused on GUnit 4 features, and GUnit 5 has recently been released, and you are most likely to see both GUnit 4 and GUnit 5. So in the workplace today, as of Java engineer, it will be up to you and your team to decide which to use on a new project. So a company standards can take a while to change, but fortunately GUnit Vintage Engine is a dependency which allows you to migrate your GUnit 4 tests to GUnit 5 more easily. So new versions always bring improvements, and as I said here, to use labeling with GUnit 4 we have to create an interface, and we have to create interfaces that we will be using them as labels, and this take time, and this is so expensive. This is why we came here with the GUnit 5, and we will use these annotations. So new versions always bring improvements. Take the add tag from GUnit 5 for instance. So using add category to label your test meant that you had to create an empty interface each time. Well, that's a waste, isn't it? So add tag is way better. You think of label and use it. Add tag Fahrenheit test would just work. So we don't have to create an interface, and we create interfaces uh, with labels. So you also get to describe your tests in plain English. So then when they fail, you are not left staring at least name like calculator tests and wondering what about the calculator that you wanted to prove. So here is the example. So in step 1 we add the tag conversion test, and we name it a conversion test, and this is what happens when the test fails. We add this annotation display name to to print in the screen this text, this string, if our test fails. So here in the step, in the second step, as I said, we we use this display name if you want to print a string if our test fails, and this is nested. At nested, we use this at nested if we want to group all the tested all our tests in a class, and that's it. So as I said before, the add tag marks all the tests as conversion tests, and add display name lets you name your tests so they're readable for anyone, and add nested lets you group tests in an inner class, and add display name and add tag to to each add test and nested block. So in step 5, many tests are grouped into nested. So this way one failing test would fail the whole group. So if one test failed, the whole group will fail here. And in the sixth step, other tests can be separated out and remain in untested, like we are using here. So when that junit 5 test runs, the results also read more naturally. So this is why we use a junit 5 in nowadays. And a lot of projects still using junit 4. So as you see here, the tests are so structured well. So to get started, import the junit 4 annotations, and you make sure that you are importing the correct one. So this is another concept that lets us create powerful tests, and so write a great test with the first principles. So we have here F is for fast, so you will know if your test isn't fast when you start running it. So accordingly to Tim Ottinger, even a quarter of a second is painfully slow. So tests can build up, especially if you have thousands of them. So I have known test suites which took hours, which makes it not feasible to run them regularly. For example, working with files or talking over a network can seriously slow your test down. So this is where it's useful to use stand-ins called test doubles. So such as mocks will explore this more in depth a little later in this part. So I is for isolated and independent. Have you ever needed to work through a complex problem by breaking it down into small pieces you could work on separately? Sometimes this makes it easier to stay focused and work your way through any issues, because one issue equal one cause of the problem equal one solution. So tests are the same when they fail. You want to understand why. So the arrange, act, and assert principles we talked about earlier in this course can help you here. So think about what happens if each test arrange its own class under this and does only one assertion per test. This ensures that your tests are using separate data, so you can isolate them from interfering with one another. And there is very little overlap at that point, and so your tests remain independent. R is for repeatable. So if you want to make your test repeatable, avoid any two tests leaking into each other. So remember the arrange from above. That's where you make sure you start your test with the new class and data your test dependent on. So using those build tools discussed earlier in the course will ensure that you can build and test your software just as reliable or on any environment. meaning meaning your test won't fail for that reason. So in testing, this new classes and the data that tests depend on are known collectively as test fixtures. S is for self-validating. So what it means is that running your test leaves it perfectly clear whether it passed or failed. So GUnit does this and fails with red, which lets you red green refactor. And also there is no such thing as an acceptable failure. So something you hear from time to time: if you can't rely on a test, it shouldn't run. So that's what at ignore is for. This at ignore annotation, we used it this annotation if for example, if you want to test a method, and if this method fails, we don't want to get this error in the screen. So this is why we use ignore annotation. So by using a testing framework like GUnit, it's utilizing assertion libraries and writing specific tests, you can ensure that if a test fails, so there will be clear and unambiguous reporting that tells you exactly what passed or failed. So T is for true and timely. And now, accordingly to clean code, T originally stood for timely. The idea was that your test should be written as close to when you write your code as possible. So by writing your tests when you write your code, both the code and test can be designed to respect first. So if your test if you test first, you're set up to truly test your code because it's made for it. S is for self-validating. What it means is that running your test leaves it perfectly clear whether it's passed or failed. So GUnit does this and fails with red, which lets you read green refactor. Also, there's no such thing as an acceptable failure. So something you hear from time to time: if you can't rely on a test, it shouldn't run. That's what at ignore is for. So by using a testing framework like GUnit, utilizing assertion libraries and writing specific tests, you can ensure that if a test fails, there will be clear and unambiguous reporting exactly. So let's take a look of naming your unit test. And as I said before, we have to pick a descriptive name of our methods. For example, if you want to write a method, you should give it a descriptive name, and the name should describe exactly what the method is testing for. So developers have come up with a number of naming conventions for tests. So Java typically uses camel case, which is a mixture of uppercase and lowercase letters with spaces, like you see, like you see in this example. So, however, when you are writing tests, your goal is to communicate with people or developers and have test results you can talk about in the real world. So, take a look of these examples down below. So, it should calculate the sum of two positive integers. So, this is an example, and here is another example. So, thank you for your attention, and my colleague will explain will teach you this, and will explain this in actions.